Hi there, this is a video about zeros of polynomials. Now when we talk about zeros of polynomials, we are looking to see where does the graph cross the x-axis, okay? So that's what we're looking for, all right? And what we do is we let y equals 0 or f of x equal to 0 and solve for x, okay? So that's the idea of what we're trying to do when we're finding the zeros of polynomials. And so solving polynomials, this act of solving for x is really what this video is about, and we're going to explore all of those different options, okay? Now, one of the words that we have to talk about is the word degree, okay? And the degree of a polynomial is your largest exponent, all right? And it also tells you the number of solutions, all right? So we'll talk more about this, but that's the idea, all right? So what we're doing, we are trying to figure out where does the graph cross the x-axis. We let y equal 0 or f of x equals 0 and solve for x. The degree tells us the number of solutions. All right, so we're going to start with degree 2 and work our way up to degree 3 and then higher order degree polynomials. All right, the first one I want to talk about is solving degree 2 polynomials. All right, and these are, we consider these quadratics. All right, we consider them trinomials. And we also call them binomials, all right? And so what we want to do is we want to think of the ways to solve, all right? And so the first way, the thing that you always want to do first is look to see, can you solve by factoring, all right? So can you factor, all right? And if yes, all right, then factor. But if no, then you want to do the second option, which is the quadratic formula, all right? So I'm going to go over a couple of examples of instances where we can, locate and solve a degree 2 polynomial. All right, so on our first example here, we've got this function f of x is equal to x squared plus 7x plus 12. All right, first step that we want to do is let f of x be equal to 0. And then we want to solve this equation for x. Now, because we're dealing with a polynomial or a quadratic, a degree 2, we have to either solve by factoring or use the quadratic formula. All right. Now, when we factor something like this, when your leading coefficient is 1, you can often ask yourself what two numbers multiply to 12 and add to 7. Okay, and that's going to be 3 and 4. All right. The other way you can do this is by using the box method. Put your first term here, x squared here, put 12 in your bottom corner. And then do x and x that are going to multiply to x squared, and then two numbers that are going to multiply to 12. Let's do positive 3, positive 4. 4 times x is 4x. 3 times x is 3x. Combine these together, that gives us 7x. That matches what we have in the middle, so we're good. And so knowing that, you can factor this to x plus 3 times x plus 4. All right, that's the idea. And then what we want to do is we want to take each of these factors and set them equal to 0. So if I do x plus 3, set that equal to 0, and then do x plus 4 and set that equal to 0, I'm going to solve each of these equations for x. And I get x equals negative 3. And then here I get x is equal to negative 4. All right. Once I have these, what I want to do is graph this equation and see where, look at where does the graph cross the x-axis. So when we graph this, we want to look to see where does our graph cross the x-axis. That's at negative 4 and that's at negative 3. All right. So that's our goal. All right, we want to be able to calculate these algebraically. You do want to make sure that you can use Desmos or a calculator to check these, but that's the idea. Let's look at another example. All right, so for this function, same thing. All right, we've got this function, and I notice it's a quadratic because we have degree 2. And so with this, set your function equal to 0, and we want to solve for x. Now, the problem with this is that this polynomial here, or this quadratic, does not factor. All right, there's no numbers that multiply to 5 and add to 3. Okay, and you can't do the box method. And I encourage you to try, always try to factor first. And if you can't, then you have to use the quadratic formula. All right, and so to remember the quadratic formula, that's x is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right, and that comes from, an equation in standard form, ax squared plus bx plus c is equal to 0. All right, so what we have to do is identify our a value, our b value, and our c value and plug it into our quadratic formula. So our a value in this case, the number in front of the x squared is 1. All right, the b value, the number in front of just the x term is 3. All right, so b is equal to 3, and then c is our constant value, and that's going to be that c is equal to 5. Okay, so plugging this into the quadratic formula is going to give us this. We got opposite 3 plus or minus the square root of 3 squared minus 4 times 1 times 5 all over 2 times 1. All right, and then this is what we want to solve, okay? So we just got to evaluate this and do order of operations. So opposite 3 plus or minus the square root. 3 squared is going to give us 9 minus 4 times 1 times 5 is 20. All right, and then all over 2 times 1, which is 2. All right, our next step down, we want to do opposite 3 plus or minus the square root. 9 minus 20 is negative 11. All right, all over 2. And so from here, you've got the square root of negative 11. You can't take the square root of a negative number. We can't take the square root of 11. So we're going to write this as negative 3 plus or minus I times the square root of 11, all divided by 2. Okay, these are our solutions, all right, because we have plus or minus, we have 2 of them. You have x is equal to negative 3 plus I times the square root of 11 over 2, or you have negative 3 minus I square root of 11 over 2. All right, so these are the values for x that you get. Now, notice that you got 2 values here, just like we did in the previous one, because our degree is 2. All right, now let's look at a graph of this and talk about what these solutions look like. So when I plug this graph into Desmos, what we're looking for is where does it cross the x-axis. And it doesn't cross the x-axis. Here's our x-axis, and this graph is just simply above it. That's why we get complex or imaginary solutions, all right? So it's just important that we're able to go through this process. So now let's look at some higher order degree polynomials. All right, so degree 3 polynomials, the first thing that we can do, ways to solve is the same thing. Now, factoring degree 3 polynomials is a little bit different. So what I want to do, the first thing you look for is, can you factor by grouping? All right, and I'll provide an example of that. All right, can you do that, yes or no? Do you have the sum or difference of cubes? Okay. That's the other one. And then if you can't do that, then we will use synthetic division to solve. So synthetic division. And so on this one, I'm not going to go through an example of how to do synthetic division on a degree 3 polynomial. I'll do another one for a degree 4 polynomial. But I want to talk about factor by grouping and then sum or difference of cubes. All right. So let's first talk about factor by grouping. So on an example like this, f of x is equal to x cubed minus 2x squared plus 5x minus 10. We first want to set this equal to 0, all right, and then go from there. And so I'm just going to copy everything down. The next thing I want to do is I want to group my first 2 terms together, and then I want to group my last 2 terms together. And this is factored by grouping, all right? And I'm just checking out to see if this will work, all right? So if we do 0 is equal to, what can we factor out of this first group? And that answer is x squared. So if we factor out an x squared, then we are left with x minus 2. Now on the next one, we can factor out a positive 5. So if I factor out a positive 5, then we are left with x minus 2. From here, you can factor out a common factor of x minus 2, and you get x minus 2 times then x squared plus 5. All right. Now I can't factor this part any further, and because I have two terms here, I'll show you how I would solve this. But this is completely factored. Once something is completely factored, we can set each of our factors equal to 0. All right, and then here, I'll do x squared plus 5 equal to 0. So on this left side, x minus 2 equals 0. We've got x is equal to 2. Now the other one, I want to subtract 5 first, and we get that x squared is equal to negative 5. I then want to apply the square root to both sides, and so then we get that x is equal to plus or minus the square root of negative 5. When you take the square root of a negative number, that's going to give you an imaginary solution. So x is equal to plus or minus I times the square root of 5. From here, I know that x is equal to I times the square root of 5, and x is equal to negative I times the square root of 5. All right, and so I have 3 solutions here. All right, hence, my degree 3 polynomial. This large exponent helps me determine the number of solutions I'm going to have. Now, regardless of whether they're real, like x equals 2, that's a real solution. These are complex solutions. Let's look at the graph real quick to see what we have. So once we show the graph of this function here, notice that we only cross the x-axis at 2. All right. The other values, because they're imaginary, they don't have any actual x-intercepts. We only have 1. So you have 1 real solution and then 2 complex solutions. Okay, on the next one, you've got some function f of x is equal to x cubed minus 27. So what I want to do is first recognize that, yes, this is degree 3, but I only have 2 terms here. This is the difference of cubes. All right, so what I can do is I can write this as f of x is equal to x cubed minus 3 cubed. All right, I want to set this equal to 0, and we get that x cubed minus 3 cubed. Now, to recognize this, what we have to do is remember what this looks like. So if I have some number a cubed minus b cubed, this is going to factor to a minus b times a squared plus a times b, and then plus b squared. All right. So that's the other one. If you had to say sum of cubes, a cubed plus b cubed, this would factor to a plus b times a squared minus ab plus b squared. All right. And from here, all right, what we want to do is just recognize that this is sum or difference of cubes. My difference of cubes is here, so this is what I'm going to use. So this is going to then factor down to 0 is equal to x minus 3 times x squared plus 3x and then plus 3 squared, which is 9, okay? And from here, this is completely factored. I can't factor this any further, all right? If we could, it would be a part of our formula that we use. But at this point, what we want to do is set each of these equal to x. Or I'm sorry, equal to 0. So x minus 3 is equal to 0, or x squared plus 3x plus 9 is equal to 0. All right, what we know is that x is going to be equal to positive 3 here, and that's all fine and good. But the other one that we need to be able to solve is this one, okay? And so from here, when you have something like this, 2 numbers that multiply to 9 and add to 3, that doesn't exist, all right? Try to factor this if you can, but it's not going to. And so from here, because of that, you want to use a quadratic formula. A is equal to 1, B is equal to 3, C is equal to 9. All right, plug that into your formula, and you get opposite 3 plus or minus the square root of 3 squared minus 4 times 1 times 9, all over 2 times 1. All right, at this point, you just want to go through and solve. So you've got x is equal to negative 3 plus or minus the square root of 9 minus 4 times 9 is 36. So minus 36 all over 2. All right, and so at this point, you get negative 3 plus or minus the square root of, so that's going to give us negative 27, and then that's all over 2. And so from here, we would do negative 3 plus or minus, I'm going to do I times the square root of 27 all over 2. X is then equal to negative 3 plus or minus, we can simplify this down to I times the square root of 9 times the square root of 3 all over 2. So then our final answer, negative 3 plus or minus 3I times the square root of 3, and then all over 2. Okay, and so that's our answer. Now, because we have an imaginary solution here, the only value that we're going to have on this graph is positive 3. Okay, so if we look at this graph, you know, what we're trying to figure out is where exactly does this cross? It crosses at 3. That's our only real solution. The other two are complex. So if you factor something and, you know, you get 3 real solutions, it'll intersect the graph at 3 different points. All right, on the last example, last thing I want to talk about is higher degree polynomials. So this is higher degree. This means 4 and above. All right, so you know, degree 4, degree 5, degree 6, all that stuff. The thing that we want to use here is synthetic division, okay? But however, the first thing you want to do is you want to graph this first. And then the second thing you want to do is use synthetic division to factor, all right? And I want to talk about what that means and what that looks like, all right? So let's look at an example of a degree 4 polynomial. So f of x is going to be equal to x to the 4th plus x cubed minus 11x squared minus 5x and then plus 30, all right? Yuck. All right, so this is a polynomial that you're being asked to solve, all right? And you got to factor this. You're going to have 4 solutions because your degree is 4, all right? So let's go through this. Now, what I want to do is I want to graph this polynomial first to know where do I start in the process of factoring, okay? Okay, so again, the first thing you want to do here is graph this, because it'll save you time when it comes to you know, using synthetic division. We want to do this in as few steps as possible, and so graphing this first allows us to do that purely based off of you know, just looking at the graph. All right. Notice that we have x-intercepts at negative 3, negative 2.236. 2, and then positive 2.236. What I want to use is I want to use x equals negative 3 and x equals 2 to start this, okay? And I'm going to show you how I go through that using synthetic division. All right, so from these, I want to make sure that these are the values that we start with, all right? So when I have my zeros, I'm going to use them and use synthetic division on this polynomial here. So I'm going to do 1, 1, negative 11, negative 5, and then 30. Okay, and so when we do synthetic division, I'm going to drop down my 1, all right, and then I'm going to do negative 3 times 1 gives us negative 3. Then I'm going to do 1 plus negative 3, which gives us negative 2. Then I've got negative 3 times negative 2, which gives me positive 6. Add these values, and so what we get then from adding those is negative 5. If I do negative 3 times negative 5, that's going to give us, what is that, positive 15. And then if we take negative 5 plus 15, that's going to give us 10. And then from there, we've got negative 3 times 10, which gives us negative 30. And what we want to make sure we do is that these two numbers add to 0. And so our remainder is 0. And when we do this, here's what we're doing when we're doing synthetic division. When we have x equals negative 3 as a factor, we have x plus 3. The result down here is a degree 3 polynomial. And so this is x cubed minus 2x squared minus 5x and then plus 10. All right. From here, all right, when I look at this specific example, we could continue. So basically what we've done is we have factored out an x plus 3 factor from this, using synthetic division. Again, to get the start on this, you have to graph it first, identify those values. Now what I'm going to do is I'm going to do synthetic division on this one using the value of 2. All right, so from here, I've got 2, then, and this is going to be 1, negative 2, negative 5, positive 10. Drop down my 1. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. Negative 5 plus 0 is negative 5. 2 times negative 5 is negative 10. Add these together, you get 0. That's your remainder. Now, because of this, look what you've done. You've done another set of factoring. So you've got x plus 3 times x minus 2. Because if x is equal to 2, the factor is x minus 2. And then we've got x squared plus 0x, which is 0, and then minus 5. This is completely factored now, and we want to set this equal to 0. Now, because this is factored, I can just set that equal to 0 and solve this. If you weren't able to factor this down again, you would have to use the quadratic formula to solve that portion. But because we don't have to do that, because we can just solve that as is, we're going to set each of these equal to 0 and solve for x. And so let's do that real quick here. We're going to subtract 3 from both sides, so we get x is equal to negative 3. All right, add 2 to both sides, so we get that x is equal to positive 2. Here we would add 5 to both sides, and we get x squared is equal to positive 5. At this point here, you can take the square root of both sides. All right, and then we get that x is equal to negative 3. You get that x is equal to 2, and then you get that x is equal to plus or minus the square root of 5. And that means that you've got x is equal to positive square root of 5, and you've got that x is equal to negative square root of 5. All right, and those are the values that were decimals, and these are the values that worked. All right, but that's the idea. So it's important that given any polynomial, you can solve it. So let's write that down. So given any polynomial, all right, you must be able to find all zeros, okay? So not only is this really important in, say, Algebra 2, college algebra, pre-calculus, but it's really important when you get to calculus, because you've got to be able to take anything and see where does it cross the x-axis. That's really important in calculus. So please reach out if you have any questions, and we'll talk to you all soon. Thanks. Bye.